All right, so today we're going to do 7.5 tangent ratios. But before we actually do tangent ratios, I'm going to talk about what is trigonometry, which is this stuff right here. So what is trigonometry, or for short, trig? Now I'm going to refer to some stuff that we talked about in the past, particularly the Pythagorean theorem stuff. We learned from the previous section, a squared plus b squared equals c squared. That means it would be a right triangle. If you had a squared plus b squared being smaller than the c squared, so c squared is bigger, that would be obtuse. And then if you had a squared plus b squared is greater than c squared, that would be acute. You don't have to copy this down. You already have this in past notes. But what I want to talk about is notice how these sides decides what type of angles you have on the inside. It turns out what that means is that there is some relationship with the sides of the triangle with the angle inside the triangle. And that relationship between the angles inside a triangle and the sides outside a triangle is called trigonometry, or trig for short. And there's three main units of trig: sine, cosine, and tangent. It's capital T. What we're going to talk about today is just tangent, okay? All right. So let's go to the actual note sheet. All right. Let me minimize my camera for this. All right. So tangent ratio, that is our goal for today. I don't know why I turned blue, but all right. All right. Now, before I fill this in, let's talk about the right triangle in general. You always have a right triangle, and these questions will always involve right triangles. And this right triangle is A, B, C. C, the capital C, is always the right angle. Now, if we're comparing it to capital A, so angle A, you have a couple of sides going on. You have the hypotenuse over here. And we know that the hypotenuse, the side across from the right angle. It's always the side across from the right angle. But here at angle A, we have a side that's across angle A. We have some side, in this case BC, that's across angle A. This BC is called the opposite side. Is the opposite of angle A, is across the triangle. So if I ask you what's the opposite of angle A, you would say BC. And we've done this before in previous triangle chapters, where we talk about the opposite side. What's something we don't usually talk about, and that's going to be relatively new today? The word is not new, but how we use it is new. We're going to talk about the angle and the side next to it that's not the hypotenuse. So this is important. It is not the hypotenuse. It's that other guy, the other leg of it. We're going to call this side adjacent. Adjacent. Okay? And if you know the word adjacent, by definition, is something next to. So if you're adjacent to something, you're next to something. This side, AC, is next to angle A, while AB is the hypotenuse. That is also next to A, but the hypotenuse is more, we could say, important title. Like someone could be a Mr. and a doctor, so you would just refer them as doctor. because that's like the more important title of the two. Okay. So we're going to fill in some blanks. A trigonometry, I'm off. A trig ratio is the blank of blank with the side lengths in a blank blank. So 2 words, it's inside a right triangle here. So 2 words are right triangle. So trigonometric ratio, this trig ratio is the ratio of what I mentioned earlier. The angles of 2 side lengths in a right triangle. So is the ratio of the angle, so how the angles are, compared to 2 side lengths of the right triangle. The ratio of the legs, and you remember these are the legs, it's called the tangent ratio. Okay? All right. Thank you for letting me know. So the legs are the tangent ratio. Now, this is something very important. Definitely write this down, box it if you need to. The tangent of theta, and we use that symbol, it's like a circle with a little line in the middle to talk about angles. So the tangent of theta will always equal the opposite side over the adjacent side. So the opposite side over the adjacent side. So when I say tan of A, so tan of A here, it's going to be the fraction or the ratio between the opposite and the adjacent side. The opposite side here is BC divided by the adjacent side, AC. All right. Now, which one is adjacent and which one is opposite is based off what angle we're talking about. So in this case, let's see, cool. This is still my hypotenuse, AB. But because I'm talking about B, because I'm talking about angle B, my opposite is going to be opposite of angle B, which would be across AB, which is CA. And my adjacent, the side next to angle B, is going to be BC.
So are you basically just like rotating them all like one way basically?
Say your question as a whole again, so I can make sure.
Are you basically just like rotating? You're rotating it basically.
Rotating would be correct because if you rotated it, hypotenuse will like land on the bottom. It's more that your starting point is different. Here, it's based off where you're standing at B. So you're standing on B and you look across the room. If you're looking across the room, AC is across of you. If you're standing at A, you look across the room, BC standing across of you.
Got it.
Yeah, so think of it like if you're in one corner of the room versus the other corner of the room, your perspective is different. It's the same thing here. Depending what corner of the room you're in, or in this case, a triangle, is going to change your perspective.
Got it. Thank
Yeah,
you.
no problem. So that means what we're going to have here is our tangent of B, our tan of B, is going to be the opposite side, which this case is AC, over our adjacent side, which this case is BC. Now, very important, the hypotenuse never changes. It's always across the right angle. Always across the right angle. And again, it's the more important title, so that's why we call it the hypotenuse. Is it technically adjacent? Yes, but it's the hypotenuse which is more important. So remember, tan opposite over adjacent. Okay. That's the most important part there. Tan is opposite over adjacent. I can't say it's the most important part because if you don't know which one's opposite or which one's adjacent, you can't do it anyway. All right. So we're going to do we're going to do this page. I think the last part is the calculator. Good. So I'll show you how to do it in the calculator too. All right. Find tan of D and find tan of F. So find tan of D and find tan of F. So we technically have two questions here, tan of D and tan of F. If I'm standing on letter D and I look across the room, I'm looking opposite of the room, my opposite is 60. So I'm going to put 60 here because opposite of me is 60. What's right next to me in the room, like over here? Technically, I have two next to me, but remember, hypotenuse is its own thing every time. So over here, what's next to me is the 45. So we have a ratio, 60 over 45. You can simplify that by taking 15 out from top and bottom, and you're left with 4 over 3. So what does that mean? Your tan of D is 4 over 3. Okay. Your next one, tan of F. Now I'm standing at this corner of the room. Because I'm standing at this corner of the room. The opposite wall is a different wall. So I look across the room and the 45 is on the opposite side. While the one next to me is 60. Take out a 15 out of both sides, 3 over 4. Now, what is the name of a fraction that gets flipped over? Does anyone want to say, what's the name of the fraction when you flip it over? It starts with a R, the word.
Improper fraction. Oh, wait,
Man, I
with
said
R.
it just started with an R. It gave me 2 words. No, it's not improper fraction. I know what you're thinking about that because the bigger numbers on top, but no, it's not improper fraction. What is it called when I flip a fraction over? It starts with an R.
Isn't it a rotated fraction?
Not rotated. R-E.
Reciprocal.
R-E-C.
Reciprocal.
Reciprocal. Good, good, good. So this is a reciprocal. So what we can say is the tans are going to be reciprocals from each other. Because think about it. Your opposite changes because you're standing at the other corner of the room. So your opposite side is the reciprocal of the other one. Because your opposite and your adjacent flipped positions. Okay. Let's talk about the next one, example 2. The triangles, this is a triangle that's rotated. So purposely so to practice the concept. You should always kind of just tell yourself, which one's the hypotenuse here? Well, the hypotenuse is the one across the right angle, which is at R. So the hypotenuse is 17. You always want to start with just telling yourself what the hypotenuse is, because the hypotenuse is your baseline. It's always the hypotenuse no matter what. So in this question, let's find tan of P and tan of Q. Side note, you never find the tan or any trig function for the right angle. You never do the tan of the right angle. So it's always the one or the other angle. So if you ever see like you're going to tan R, you know you're making a mistake. And you will have an awkward situation because your opposite would also be your hypotenuse, which would be weird, especially in the other ones. All right. Tan of P, tan of Q. P is going to be here. I'm looking across the room. Across the room is an 8. And what's next to me is a 15. 8 and 15, nothing in common. We're done. That's nice. Other side, now I'm standing on Q. I look across the room. 15. I look across the next to me, an 8. So 15 over 8. All right. We're going to save the calculator stuff for another day. Does anyone have any questions about how to say which one's opposite and which one's adjacent? All right. If so, then I'm going to give you an exit ticket real quick. Let me make a right triangle. A, B, C, 6, 8, 10. Everyone, to leave the class early, you're going to have to type to me what is tan of A and what is tan of B. You need to simplify the fraction too when you send it to me. So when you type it out, I would type it out like tan A equals, I don't know, like 8. Well, I don't want to put the answer. So like 11 over 2. And then tan B equals 2 over 11. Something like that. This is not the right answer, so. But that's how you would type it to me. Yeah. So if you type me both and they're both correct, you're free to go, and I'll count for your attendance. If you don't know how to do it, just wait a solid minute and a half, and I'll just explain it once more. Remember, you want to simplify the fraction. Morty, good to go. Excellent job. You're free. Have a wonderful day.
Thank you.
No problem. Ethan, you got to simplify and make sure you privately message me too. Careful, guys. Try to privately message me. So, no, your opposite and your adjacent got flipped. Remember, it's opposite over adjacent. Ellie, private message, please. And you can leave it as an improper fraction. You don't have to change it into a mixed number. Mosh, you
bad,
got
my
the
bad.
first one good. Julia, you got both of them. You're free to go. Ellie, I won't say it's right or wrong, so send me a private message. I'll tell you if it's right or wrong. More Mosh, you got the second one. You good to go?
Thank you. Have a good weekend.
No problem. You too. Angela, you're good to go. Again, you don't need to change it into a mixed number. If you like that, that's fine, but you don't have to. Maybe that's a little too much work, okay? So you're good to go. Ellie, you got it. You're free to go. Lael, you got it. You're free to go.
Have a good one.
Shul, I'm not sure what you're saying, so I'm trying to read it out. Ethan, your B is correct, but your A, you did something wacky with your simplification. I don't know what. Oh, Shaul, simplified that fraction 2/6 for me. Because it should be simplified. Ortel, great job. Oh, okay, Ethan, then you're free to go. Have a wonderful day. I understand that. Shaul, you got it. You're free to go.
Thank you.
No problem, man. Shaul, you got both of
All right,
them, so
thank
you're
you.
free to go. Have a wonderful day.
All right, thank you. Have a good day.
No problem. Guys left. Do you want me to go over it?
Yeah.
Yeah.
All right, solid. So I'm gonna ask Sam for one, and then I'm gonna ask Zach for the other. Okay. So Sam, I'll give you first. If you're standing at A, okay, you're standing at A. Which one of these numbers is opposite of you?
Both of them, isn't it?
No, opposite.
Not sick.
6, good. Opposite is very particular. That's across the room. Now, if I asked you which one was adjacent, you could technically say 2 options, but one of them's the hypotenuse. So what's the one that's not the hypotenuse that is next to A? You could think of it as connected to A.
It's 8.
8.
Right.
Good. So 6/8 reduces to what?
It's
3/4.
3 or 4. 3 or 4.
Good. 3/4. Thanks for the assist on that one. Now, Zach, it's going to be up to you. You're standing on
Right.
B. You're standing on B. Wait up, Sam, because I just want to make sure you got both sides. Sam, Zach, you're standing at B. Which one's opposite of B?
It's 8, I think.
Uh-huh. And then what am I going to look for next? Am I
All right, I
look-
think 10's the hypotenuse, so it would be 8/6.
Good. 10 is the hypotenuse. 8/6 is the fraction you need. Simplify that. You could also think of it as the flip of this. So 8/6 becomes
Yes, it would
what?
be 4/3.
4
4
over
over
3.
3.
Yeah, perfect. Okay. Both of you guys, you're free to go. You
All
don't have to type anything. Have a wonderful day.
All right, thank you, Mr. Stoll.
Hey, no problem.